Hi. So first, I just want to thank everyone for being here. I know that a virtual conference presents challenges for some people, and so I just wanted to thank everyone who was able to make it here today. That said, the title of my talk today is Illusory Causal Connections and Their Effect on Subjective Probability. And my guess is that this phrase, illusory causal connections, doesn't make a lot of sense at first, but my hope is that by the end of this talk, it'll be clear both what we mean by illusory causal connections and also how we think this is important for understanding of subjective probability in general. So first, I just wanted to observe something about subjective probability in the real world. So if you think about the weather is something that's probabilistic or at least pseudo-probabilistic, or we think about it as such. And yet, if it doesn't rain for a long period of time, it's not as if you feel that it must rain the following day. Let's say it hasn't rained for 2 weeks. You're not thinking, oh, it has to absolutely rain tomorrow, or it must snow tomorrow, or something like this. You might think that sometimes, but on the whole, I don't think that's the way we think about how weather works. This is in contrast to how we think about other probabilistic events, like in a gambling setting. The well-known gambler's fallacy tells us that when you lose repeatedly a gamble, for some reason you think you're more likely to win. You think that because something hasn't happened, it's somehow become more likely to happen in the future. And I'm not saying that either of these two things are definitively always the case. I just think that in general, we have different tendencies of thinking about these things and other events. The purpose of the talk today is to observe that our world is probabilistic in many ways, but that we don't always think about it as being probabilistic in the same way across a lot of different scenarios. So today I'm going to talk about a case study, or really two different case studies, that highlight the ways in which we consider the world as being probabilistic in very different ways, despite the same underlying sort of probabilistic structure of a problem. So with that, we can jump right into our first case study. Our first case study is very straightforward. You can imagine a jar with marbles. In this case, let's say that there's 20 marbles, 19 of which are blue, one of which is red. And the way that you play this game out is that you select a marble, you note its color, you replace the marble, and you do this iteratively 20 times. And what participants are told to do in our task is just to tell us how likely they think they are to win in this case. So winning here again means that at least once in those 20 selections, you get a red marble. It doesn't matter if you get it 1 time or 20 times, as long as you get the red marble at least once, you're going to win. So I'll pause here for just a moment to let you all think about what your own answers would be. Cool. So the actual answer in this case is about 64%. So you can hold on to that information, and in just a minute I'll tell you what our participants thought. But first I wanted to go over what our actual prompt looked like to participants. So here's the full vignette that they get to read. It's pretty straightforward, but I do want to highlight a few specific things that we did. The first is that we gave people this information in terms of probabilities and frequencies, just to cover our bases. The other is that we always gave this hint that the answer is neither 100% nor 5%. The reason we did this is because we noticed a decent number of responses where people were misunderstanding the question. So for example, one common thing is that people thought we were tricking them, and we were asking about the probability on any given trial, but that's obviously not the case. So we wanted to make sure they knew that we weren't asking them about the probability on any given trial, so the answer would be 5%. And then the last thing that we did is we told them to think about it like a coin flip, or to think about how coin flips work, in the sense that there's a 50% chance that you'll get tails on any given coin flip, but that doesn't mean that you're guaranteed to get tails after 2 coin flips. So we wanted participants to understand that there's nothing that's guaranteed about the outcomes here. And then finally, we just had them rate their probability judgment. They did so by adjusting sort of a sliding scale like this, and they can see the answer on the bottom of the screen. So here on the y-axis, we have people's mean probability judgments. On the x-axis, we have 3 different numbers of selections. So everything that I've shown you so far is 1 out of 20 with 20 selections, but we also did 1 out of 100 chance with 100 selections, and the same for 300. These situations are very similar. The probabilities are not exactly the same, but they're all about 63 or 64%. So they're mostly the same. So here's what participants thought. You'll note that the actual value here is about 64%, which is represented by where the x-axis is. And so you'll note that participants on the whole are quite pessimistic about their likelihood of winning in this case. They don't think they're likely to get a red marble in this case. So this should not come as a surprise at all. In fact, there's been work going back to the early 70s suggesting that people underestimate disjunctive events, and that's exactly what's happening here. People are pessimistic about their probability or their chances of winning sort of a disjunctive gamble. However, the point of my talk is to introduce another scenario in which people don't necessarily have this intuition. So similar kind of problem, except we tell participants about a button. We say there's a 1 in 20 chance anytime you press the button that you'll win a prize. You're going to press the button 20 times. What's the likelihood that you're going to win one or more prizes? Here's the scenario that I showed you before. And we just modified it to be about buttons rather than marbles and jars. And the reason that I did that silly animation there is to show you that the actual language about probability judgments is staying the same. And the only thing that we've changed here is just that we're now talking about a button instead of marbles and jars. So here are the data that I showed you before for the estimations for the marbles and jars case. And now here we can see the estimations for the button pressing case. And immediately what you can see is that people have very different intuitions about their likelihood of winning in this case. Now, you might be tempted to think that people are more accurate in the button pressing case, and therefore they're being irrational in the marbles and jars case. But I would remind you that we gave participants some very overt hints about what the answer was not in our prompt. And if we haven't done that, so in our pilot data where we did not do things like that, participants' judgments in the button pressing case were much higher. So in other words, we don't think it's the case that they're underestimating in one case and being accurate in another case. We think they're actually underestimating in one case, overestimating in another case. And I'll show some more data that sort of fleshes that point out a little bit more. But the main thing that you want to take away here is that people's probability judgments are quite different. If you look at just 300, for example, there's about a 30–40% difference in people's estimates, even for problems that are formally identical. So I'll explain a little bit about why we think this is the case, but before I do that, I just wanted to show some converging evidence to show that both of these effects replicate and are quite stable. In our first experiment, we just asked participants very explicitly what they thought. In this experiment, we wanted to probe their judgments a little bit more implicitly. So we gave them a choice between two gambles, one of which was the same disjunctive gamble that I showed you before, 1 in 20 odds, you select 20 times. But they could choose that or a simple gamble in which they made only a single selection, but the probability was much higher. So in this case, say there's 12 red marbles, they have a 60% chance of winning. Now, if participants are being rational, they should choose the disjunctive bet in this case because they're slightly more likely to win. So I'll show you the data. On the y-axis here, we have the number of participants choosing the simple bet. There were 100 participants. You can also think about this as the proportion. On the x-axis, we have 3 different values of the simple bet. So what I just showed you is 60%, but we also tested in separate groups of subjects, 65 and 70%. And here's people's responses. Across the board, you can see that people prefer the simple bet, suggesting that once again, they're pessimistic about their likelihood of winning in the disjunctive bet. Now, in stark contrast, when we give participants exactly the same kind of scenario, but about the button presses, people are much more likely to favor the disjunctive bet on the whole. And one thing I want to point out here is that the values along the x-axis are not the same in these two experiments, and that is by design. What I want to bring your attention to is this contrast right here. So this is a case where the simple bet probability was set at 65%. And what you can see is that in the marbles and jars case, about 3/4 of people preferred the simple bet, whereas in the button pressing case, about 3/4 of people preferred the disjunctive bet. So this is a massive dissociation in subjective probability that hinges on a pretty superficial distinction in how these disjunctive bets are framed. So one thing we wanted to know is that participants were really understanding the question. So did they really understand what we meant by one or more? Were they responding just the probability of getting one prize? There's a lot that we can't really tell from the previous data. So in another experiment, we asked them to consider the whole problem, well, at least a little bit more of the problem. So instead of asking them, what's the probability of getting one or more prize, we would say, hey, what do you think is the probability of getting exactly 0 prizes, exactly 1 prize, and then more than 1 prize? Of course, this represents the whole world of possibilities. So these values should add up to 100%. We told participants that very explicitly. And if they adjusted their answers in such a way so that their answers did not add up to 100%, they would get a warning and they would be reminded that their answers needed to add up to 100%. So here's the data. On the y-axis, we have the mean probability estimates. On the x-axis, we have those 3 different values. So what's the probability you'll get 0, 1, or more than 1 red marble? And then these gray bars correspond to the actual values. And here's what participants thought. So you'll note here that 60%, on average, they think there's a 60% likelihood that they'll receive no prizes at all. which I'll note is almost perfectly congruent with what we found in the first experiment, and that they're pessimistic both about the probability of receiving exactly one prize and about the probability of receiving more than one prize. In comparison, we have the button pressing case in which they think there's only about a 25% chance that they'll receive 0 prizes. So that's about a 35% difference in their likelihood of receiving any number of prizes. And you can see that they're more optimistic relatively about receiving both one prize and more than one prize. This is just another way of saying that our results replicate even when participants are forced to think about the constraints of the problem. The other nice thing about these data is that they converge very nicely with the results of the first experiment that I showed you. So we've come to think of this as a sort of reservoir fallacy, and I'll explain what we mean by reservoir fallacy. I do want to say at the outset that there's nothing about this effect that hinges on this name. This is just one way of thinking about it that's been helpful to us, but I'll tell you at least one other way that you could think about these results. The other thing that I want to highlight is that the fallacy that we're trying to identify here isn't about one scenario or the other. It's about the difference between the two scenarios and the fact that people seem to think very differently in these two formally identical but superficially different scenarios. So the way that we think about this is that we think that people have a mental model that includes a reservoir that represents essentially the world of possibilities. And we think that we imagine the outcome that's desired is like an object hidden somewhere in this reservoir and you're trying to find it. So if you take the button pressing framing, what we imagine is that you press the button and the reservoir depletes a little bit. That event is related to some depletion of the reservoir. And that each time you press the button, the reservoir depletes a little bit more. And so the world of possibilities is shrinking, but of course the outcome is still in there somewhere. So you're increasingly likely to find the desired outcome. Now, in contrast, if you think about the marbles and jars framing, you select a marble from the jar, the reservoir depletes just like it did before, but because you're forced to think about the fact that you have to replace that marble, the reservoir also repletes, or your mental reservoir also repletes. And so when you select another marble, again, the reservoir depletes, but then it'll replete again and again, such that the probability is relatively constant across iterations, and as a result, you're a little bit more pessimistic. So there's two more things I want to say about this. The first is that perhaps now is a little more clear what we meant by illusory causal connections. Essentially, the idea here is that in the marbles and jars case compared to the button pressing case, we think people have different causal models of the world that they're bringing to bear on these cases of subjective probability. So for some reason in the button case, there's some sort of causal model about that system where the events are not independent, whereas in the marbles case, you're forced to recognize the independence of those events. And it's that higher level causal model that seems to be having a lot of influence on people's subjective probability estimation, rather than any particular intuition they have about this kind of probability judgment. The other thing I want to say is that if you don't like this whole reservoir idea, it's sufficient to just say that in one case people have a greater sense of the independence of events, and in another case they have a greater sense that those events are interdependent. We still think there's a higher level causal model that people bring to bear, but whether you wrap that up in the reservoir fallacy is totally up to you. Of course, the value of this perspective is in our ability to predict other intuitions that people might have. We run several experiments that try to address some of the ways that this might matter in the real world. I'll just have time to show one of them to you today. So we wanted something that both connected with some prior work and also was maybe something that people actually encounter in their lives at some point. So we turned to dice rolls. The way this experiment worked is that you could imagine that you have some 20-sided dice, and we told participants that they're going to roll 20 of these dice, and their goal is to get ones on these dice. So our manipulation was very simple. In one case, we told participants, hey, you have one die, you're going to roll it, see the outcome, roll it, see the outcome, etc. You're going to successively roll that single die. In another case, you have 20 dice, and you're just going to roll them all at once. What do you think your odds are of getting exactly 0, 1, 1, 1, or more than 1, 1? And here are those data. This is the same kind of graph that I showed you in the previous experiment. On the y-axis, we have people's mean estimates for each of those possible outcomes. And what you can see is that even in this very simple manipulation, we're just encouraging people to think about successes versus simultaneous dice rolls. There are dissociations in people's responses so that people are generally more optimistic in the simultaneous rolls condition. And the reason we think this is because there's something about that system that people think those dice rolls are interdependent in some way, that they affect each other in some way, compared to the successive rolls condition where you're forced to think about the independence of each dice roll because um, uh, they're happening one at a time. So in sum, we think it's pretty clear that people's probability judgments are being influenced by some sort of higher level causal models of the world. And so we think this is something that could apply sort of broadly across this field of subjective probability. The other thing we want to point out, just sort of concretely, is that the original work documenting effects of disjunctive events is over 40 years old at this point, so it's a very well-cited paper. It's just been taken as fact that we underestimate the probability of disjunctive events. And what this work shows, if nothing else, is that that's clearly not true across the board, and there's clearly more we need to understand about the higher level intuitions that people have that are influencing these lower level judgments of probability. So with that said, I just want to thank my collaborator, Frank Kyle, and to thank all of you once again for listening. Thanks so much.